मॉर्निंग बच्चे। आज की लेसन्स में हम बहुत इम्पोर्टेंट दो कंसेप्ट्स कवर करेंगे। एक तो फ्लेमिंग्स लेफ्ट हैंड रूल वर्सेस राइट हैंड रूल की डिस्कशंस है, जिसके बारे में हम पहले फ्लेमिंग्स लेफ्ट हैंड रूल के बारे में बात करेंगे और कहाँ कहाँ ये अप्लाई होता है और कैसे हम इसकी न्यूमेरिकल्स इजीली सॉल्व कर सकते हैं, इसके बारे में बात करेंगे। उसके बाद उसके इमीडिएट बाद हम राइट हैंड रूल, फ्लेमिंग्स राइट हैंड रूल के बारे में बात करेंगे और वो कहाँ कहाँ अप्लाई होता है और कैसे होता है उसके बारे में बात करेंगे। So today's lesson is basically for the differences between the Fleming's left hand rule versus the right hand rule. बहुत सारे बच्चों को ये कंफ्यूजन होता है कि फ्लेमिंग्स लेफ्ट हैंड रूल सर कब यूज होता है और राइट हैंड रूल कब यूज होता है, हमें पता नहीं चलता है। देखिए, इट्स अगर सही से सोचेंगे आप तो आप देखिए कि फ्लेमिंग्स लेफ्ट हैंड रूल कब यूज होता है। एक मैग्नेटिक फील्ड, अगर एक यूनिफॉर्म मैग्नेटिक फील्ड ऑलरेडी प्रेजेंट है, मैग्नेटिक फील्ड ऑलरेडी प्रेजेंट है, आई एम टॉकिंग अबाउट, ध्यान रखिएगा मैं जो वर्ड बोल रहा हूँ, यूनिफॉर्म मैग्नेटिक फील्ड इज ऑलरेडी एग्जिस्टिंग। और ट्रेडिशनली इसको आप एनसीईआरटी बुक से या किसी टेक्स्ट बुक से देखिए, आप जो इनटू साइन होता है दैट इज इनटू, इनटू मीन्स इनटू द plane of the blackboard, it is going inside, right? And this is for the circle, or the zero is the notion for the out of the plane, out of the plane of the blackboard. So when there is one uniform magnetic field already existing, right, and it happens that a current carrying conductor, अच्छे से याद रखिए, current carrying conductor is subjected to a uniform magnetic field. A current carrying conductor, this conductor carries a current, right, and is subjected to a uniform magnetic field. Then there is one force generated on this current carrying conductor. आप पीछे से जाइए तो लॉरेंस फोर्स से आप whenever a charge is subjected to a uniform magnetic field, उसी चार्ज को एक फोर्स मिल रहा था, लॉरेंस फोर्स, राइट। सेम आप एक करंट कैरिंग कंडक्टर को अगर यूनिफॉर्म मैग्नेटिक फील्ड्स में रखेंगे तो क्या होगा, ए फोर्स विल बी प्रोड्यूस्ड ऑन दैट करंट कैरिंग कंडक्टर। सो टू फाइंड which direction the force will be applied on that current carrying conductor, उसको हम फ्लेमिंग्स लेफ्ट हैंड रूल की थ्रू से समझते हैं, ठीक है। फ्लेमिंग्स लेफ्ट हैंड रूल ये क्या बोलता है, स्ट्रेच योर फिंगर्स ऑफ द लेफ्ट हैंड, स्ट्रेच द थंब, द फर्स्ट फिंगर एंड द मिडिल फिंगर ऑफ योर लेफ्ट हैंड mutually perpendicular to each other, mutually perpendicular to each other, and if the first finger is representing the direction of magnetic field, the first finger represents the direction of magnetic field and the middle finger represents the direction of current carrying conductor, direction of the current in the conductor. Then the thumb will be telling you the direction of the force, right? This is what the Fleming's left hand rule is. So what is it used for? The Fleming's left hand rule is used for finding the direction of the force acting on the current carrying conductor, right? Which direction the current carrying conductor will move, which direction the current carrying conductor will move, there we use the Fleming's left hand rule, right? And the derivations and everything you have done in your class already. So force is BIL, or how much is the quantity and what is the direction, that you will be finding easily by using the Fleming's left hand rule, right? But when the situation is such that there is one uniform magnetic field already present, it is present the same way, the notions I have told you already, either into the plane or out of the plane. To explain you on the board, right, it is given to you, and whenever there is a conductor, a straight conductor is moving in this uniform magnetic field, or there is a change in magnetic flux associated with that conductor, then what happens? That conductor is getting one induced EMF. That was not having the current from earlier, but it was without a current. Now there is one induced EMF due to Faraday's laws, which you have studied already in the classes, right? What you have studied there is whenever there is a change in magnetic flux, whenever there is a change in magnetic flux associated with that coil or the rod or the conductor, then there will be one induced EMF. EMF means volts, potential difference. There will be one induced EMF generated. And if induced EMF is generated in a conductor, definitely the current will be flowing, right? So current is generated. So right hand rule is used when you are generating current. Rate of change of magnetic flux is directly proportional to, you studied in the class, rate of change of magnetic flux is directly proportional to the induced EMF, right? So what is the difference between the Fleming's left hand rule and right hand rule is, one is using the current, and another is generating the current, right? So right hand rule is typically used when generation of induced EMF, induced current is happening, right? Like in the case of generators, in the current carrying rectangular loop, if magnetic field is already there, two magnets, north pole and south pole, creating a magnetic field, and you subject one loop, metallic loop, and the loop moves, there will be a flux changing, and because of the flux change there will be one induced EMF as well as a current in that wire, right? That is the principle of generator also you studied. And left hand rule is what? Already current is there, magnetic field is there, and you use it to get a torque, you get a direction of the force acting on that current carrying conductor, like in the case of the fan. Already magnetic field is there, current carrying conductor is there, and you are getting the direction of motion, right? So I hope you are clear about where will you use the Fleming's left hand rule, for finding the direction of the force on the current carrying conductor. And when will you get use the right hand rule? When the induced EMF or the current is generated because of the rate of change of magnetic flux. Am I clear? So in the left hand rule, the first finger is representing the magnetic field, the middle finger is representing the current carrying conductor's direction, and the thumb will tell you about the force, direction of the force, right? And when you are using the Fleming's right hand rule, the right hand, the first finger, again the magnetic field, direction of the magnetic field, the thumb will be representing the force or the motion of that conductor, and the middle finger will be telling you the direction of the induced EMF as well as the current, right? So use right hand rule and use left hand rule very judiciously without a confusion, because when you are applying wrongly you will not get the answers even for the MCQ type questions. When you are applying it wrongly you will not get any type of numerical solved, you will not get the MCQ solved, and overall you will be having a confusion, right? So please keep in mind that whatever is obtained in your immediate surrounding, use that one to understand in a better way what is and how is the left hand rule and the right hand rule used for, right? So for example, this is mutually perpendicular to each other, and you will be imagining yourself keeping the first finger in the direction of magnetic field. Suppose there is one magnetic field acting on the plane of the blackboard, right? So the first finger you will be keeping in the direction of the magnetic field that is on the plane of the blackboard. And if there is a conductor, there is a current carrying conductor, keep that mutually perpendicular to it. Mutually perpendicular to it. And you will be finding the directions easily, right? When you are keeping the field, the current carrying conductor and field and the current carrying conductor, the direction of the force on the current carrying conductor will be easily found, right? So whatever is available in your surrounding, use that one to get the basic understanding of your left hand rule, right? Many times magnetic field is acting on the plane of the board, right? Many times it is given like it is into the plane of the board. Many times it is given like out of the plane of the board. So don't shy away, okay? Wherever you are sitting in, either in the classroom or the examination hall, doing like this is not a crime, right? You are not indicating to any other person, but you imagine which direction the magnetic field is, which direction the current carrying conductor is, and which direction the force will be, right? So Fleming's left hand rule. Whenever the right hand rule you are applying, again the first finger will be for the magnetic field, the thumb will be the motion, direction of the motion, and the middle finger will be the direction of the induced EMF or the current. Am I clear? अच्छे से अप्लाई करोगे, राइट? सो generally in my experience, let me tell you one common mistake the children do when they use the left hand rule or right hand rule. सर ने तो बताए थे म्यूचुअली परपेंडिकुलर टू ईच अदर, और क्या करते हैं वो फर्स्ट फिंगर को बेंड कर देते हैं, फर्स्ट फिंगर को ऐसे बेंड कर देते हैं, मिडिल फिंगर को ऐसे स्ट्रेट रख देते हैं और बोलते हैं सर वो आंसर नहीं टेली कर रहा है, आंसर नहीं मिल रहा है मेरे को. प्लीज the first finger either of your left hand rule or the right hand rule, the first finger is always to be pointing to the direction of magnetic field. एक कॉमन चीज तो समझ जाओ, मैग्नेटिक फील्ड की डायरेक्शन में the first finger should be kept, right? Then the other things, like if it is a current carrying conductor, then keep the current carrying conductor in this way for the left hand rule, and you will get the direction of the force acting on, right? And for this also again right hand rule you are using, then the magnetic field is again the first finger, so keep straight, first finger is always straight, then thumb and the middle finger should be mutually perpendicular. So all three should be mutually perpendicular like this. Am I right? Left hand is using the current and right hand is generating the current, right? So to remember this one easily, right hand is always used for what? Good purposes, auspicious things, eating, if you are not a lefty, of course, right? So this is used for generation and this is used for consumption. Okay, लेफ्ट हैंड से हम कंज्यूम करते हैं. फैन क्या कर रहा है? कंज्यूम कर रहा है, राइट? इलेक्ट्रिसिटी को कंज्यूम कर रहा है. और जब कंज्यूम कर रहा है तो किस रूल से कर रहा है? फ्लेमिंग्स लेफ्ट हैंड रूल आप यूज करोगे, राइट? और जहाँ प्रोड्यूस हो रहा है, generators, hydroelectric dam projects, or anywhere the electric current or EMF is generated, वहाँ क्या यूज करोगे? राइट हैंड, फ्लेमिंग्स राइट हैंड रूल. और ये फर्स्ट फिंगर को हमेशा स्ट्रेट रखना, फर्स्ट फिंगर को स्ट्रेट रखना, मिडिल फिंगर्स और थंब, ऑल थ्री शुड बी म्यूचुअली परपेंडिकुलर टू ईच अदर. ठीक है? और जिस सिचुएशन में जैसे भी क्वेश्चन है उसको आप सॉल्व करना उसी हिसाब से रख के, राइट? ठीक. अब बहुत सारे टाइम ये ऑब्जेक्टिव टाइप क्वेश्चंस में या आपकी कॉम्पिटिशन्स में या सीबीएसई में भी बहुत सारे टाइम क्या करता है कि इलेक्ट्रॉन की मूवमेंट को देता है, कि इलेक्ट्रॉन की मूवमेंट को देता है ऑपोजिट टू द ट्रेडिशनल चार्ज. ठीक है? तो जो करंट कैरिंग कंडक्टर हम यहाँ बात कर रहे हैं वो ट्रेडिशनल चार्ज की डायरेक्शन को बताता है. ठीक है? तो अगर इलेक्ट्रॉन की है तो आप ऑपोजिट, उसके ऑपोजिट यूज करिए, अप्लाई करिए. एम आई राइट? तो जब भी आप यूज करेंगे दोनों रूल्स को, फ्लेमिंग्स लेफ्ट हैंड रूल को और राइट हैंड रूल को अच्छे से धीरज के साथ विथ कंक्रीट कंसेप्ट के साथ आप उसको यूज करिएगा, नहीं तो आंसर आपकी गलत होगा. ओके? तो आप ये अगर समझ गए तो आप नेक्स्ट क्लास में आपको मैं लेंस लॉ, जो one of the another confusing thing for children is the Lenz law, how the induced EMF is produced and how the opposition to it happens. The conservation of energy will be explained in the next class. ठीक है? So do subscribe to my channel if you have not subscribed yet and have better understanding of all the basic concepts. Though I will not be deriving here in my class, I will be touching on what are the basics which are generally confused amongst children. So I am talking about motivationally how to deal with the things, not to derive the things, not to go for the traditional classroom method of making notes and giving notes and sharing things. But yeah, I always see something which is happening across the educational world, then I tend to share something which is one confusing statement or confusing concept for children. Okay? So do well and please share and like also my channel as well as my video lessons, so that I will be motivated and you will be motivated further and blessed. God bless. Do well. Good day.